All right, pardon the interruption. I guess that last little segment was pretty short, and we got done kind of quick. Um, but I think we figured out this. We figured out that this acceleration is, how do you, if 1g is 9.8, what is 2g's? Well, of course, 19.6. But anyway, and then acceleration, mass times acceleration. Now, okay, so that is her force. Using our wingsuit jumper's kinetic energy and force, how far does she go before she comes to a stop? Okay, so I'm making you do that problem again. This is standard Physics 210 fare. In fact, they just took an exam over this kind of stuff, but they weren't allowed to use energy because they don't know about it yet. You're 2 weeks ahead of them. All right, and so how far does she go before coming to a stop? Well, you know how to do that. You take the force in 18 up here, where F is equal to 55 times the 2g's. Now, don't put 2g's there. Remember, it's 19.6. Okay, and then so on 19, the force times the distance, and we're trying to solve for the distance, is equal to the kinetic energy you got in problem 16. And that's your problem 16 answer. Okay. And then last but not least, in 20, we want to know how long it took her to come to a stop in that amount of time. So it's not too hard because we know the acceleration. Since we know the acceleration, that's pretty easy. We know her speed, which was 150 miles per hour in meters per second, which I think comes out to be like 49.2 meters per second. There you go. You had to come all the way here to hear me say that, but 49.2 meters per second minus 0 divided by that acceleration from 17. So you take that 150 miles per hour minus 0. Don't forget to change it to meters per second, though. Divided by the acceleration, which is the acceleration you learned in problem 16, which is 2g's. And that's how quickly she'd come to a stop. All right, have fun with this. I know it's a little bit crazy, but gosh dang it, you can do it. All right, and this will be the only. Well, I can't say things. One of the things I'm trying to keep these units so that they stay with the course coming over. Okay, in other words, what I'm trying to do is let me actually talk to you here. Uh-oh. There it goes. All right. And for those of you who are taking this class in future years or semesters, you're going, oh, okay, now I get it. But what I'm trying to do is make a nice, like, standalone video book, really, of the class. And so I can just copy it over. And but what I want to do for even 3 semesters from now is before each lesson give a little pep talk or something live, so that if you're taking this course online, you know that there's a real live person out there watching after you, looking out for your best interest, and trying to teach you some physics. Okay, so want to make sure that that's known. All right, so other than that, we are done with this lesson, and I know it was tricky, but enjoy.